Right here, yeah. So in the tradition of my title slightly changing every time I say it, I've got easier. I put easy in the program, and I will say that I'm here to talk to you, ladies and gentlemen, about how we can make data integrity easier, so that maybe that's a little bit more positive and I'm not just asking the question. Yeah, some of you in the audience will know of what I speak, that in the industry we have learned about things that we need to do in order to be good custodians of data for our customers, but it's not necessarily easy. So before I go on, I'd like to recognize the people who began these slides that I have, which are also Googlers, who gave the version about it, about what we should be doing to be good custodians of data. And I think it's a credit to them that I believe that that's now well understood in the industry. I'd also like to thank Sarah for improving these slides a lot. But as I said, I'm going to talk to you first about what it is we in the industry believe we know about what data integrity requires, why that's hard, and I'll give you my opinion about what we can do to make that easier, what we can build to make that easier. Because if we make it easier, we'll also do it better. Because what's not done easily doesn't really get done properly. Having said that, you're all professionals. I'm not here to tell you how to do things. And in fact, I'm not even here to say that Google has some magical solution to it all. Though maybe we have. I'm not here to tell you we don't. Mostly I'm here to start a conversation, like start a call to action, because I think that this is one area where we're sort of within spitting distance of making an important thing a lot easier, but we need to get some communication going in order to make the lifecycle of data work better for everybody. So to get some sense of the importance of data integrity, we can think in terms of the growth of data. So we've just had some people talking just within the ML area about all of the data in the form of original training sets and the models that they use, etc., growing in scope, growing in the amount of usage. And that's, of course, a huge area of growth, and there are many others. Data in some form is always becoming bigger in volume and used more. And both of those things both make it more important and more technically challenging to take care of it. Another way of looking at or quantifying the importance of data is to translate it into our favorite SRE languages of SLOs or SLAs or whichever vowel you like at the end. When we think about availability, about uptime, 4.9 sounds like a good number. And what that accounts for is that users are using your service, and each of them might get an hour or so of 404s or 500s or something every year. That's not pleasant, but people live. Now imagine if you had 4 nines in a kind of naive way for data integrity. That means that for a 2 gigabyte database, your documents get randomly redacted. Your apps don't run. Your database is a data waste. And the worst thing of all is that your cat videos become pixel monster videos. So that's not good even if it happened at that level. Now, if you have a 2 petabyte data set, then perhaps all of that sort of thing is happening to millions of users. So clearly that's not acceptable, and no one is working that badly. It's just, if we want to measure it in nines, it's probably something in the 12 nines or something that we're working at, which is probably why we don't usually think of it in those terms. But it's got to be much higher than what we normally think about. So in order to achieve that, what do we need? And this is where I'm saying that I'm not here to tell you anything new. I think the industry's learned that what you need is to be able to recover your data. That sounds obvious, but there's possibly more to data integrity than that, there's possibly not losing your data in the first place. But thinking in terms of recovery is nice because it pulls in a lot of stuff. Because it pulls in restoring the data, having backups perhaps, if that's how you're fixing things, or maybe you're building it from a prior source of truth, or you have replication, and if you haven't replicated the bad data everywhere, you might be able to fish it out from your good replicas. Whatever it is, there's all of that involved in recovery. But fundamentally, recovery is not just about getting the good data. It's about getting the good data serving in production without breaking everything else while you did it. And that usually takes some thought and experimentation and work. And it takes a plan if you don't want to end up like that guy. So if you don't want to end up like this guy, you need to know that, well, first of all, that you really did, you back your data up, if backups is what you're doing, that you can find the data, that you can recover it. You need to know what's going to happen when you try and recover it so you know what might break. You need to know that you have what it takes, as in you have the network bandwidth or the storage or the processing when you do your comparisons or when you do your data transformations, and that in the process you're not going to break anything. I mean, imagine if you had a somewhat damaged database and then you went and overrode it with a backup that turned out to be empty data or something, and now you have no database. You don't want to do that. And can you recover it quickly enough in terms of an emergency, where quickly enough depends on your situation. So you need to know that, and you need to know all of that before the bad thing happens, long before. So that's why we are told that we need, sometimes they're called backup plans, better if they're called restore plans, but really they should be called recovery plans because it's about getting the data back into serving. And when you have a plan, it won't work. If all you have is a plan, the idea is that you're going to try it out. You're going to find out that this permission doesn't work. You haven't got storage there. Something will fail. So you have to go and do that work of smoothing that out and then get it to the point where a robot can do it, then getting it to a point where a robot is doing it, because then you don't have to, in the last minute, remember what you're trying to do and look through old documentation or whatever. And if a robot's doing it, if you now have code should be tested, and that way you're always doing it, always finding out what the problem is, detecting problems early, and resolving them early. That is, or at least, I think for most of us, that's already a gentle introduction to what's already known. And in fact, I haven't gone into the wonderful jargon of RPOs and RTOs, et cetera, and I don't intend to in this talk. And if you don't know what they are, you don't need to know. But what I do want to go into is that even though we're supposed to do all of that, it's hard work. And we shouldn't be afraid of hard work. But if for every different data set, data store, database you have that is part of your system, you have to go through all of that again, then it's also toil. So poor Sisyphus here, he doesn't roll the rock up the mountain once. He rolls it up for eternity. And we don't want to be doing that. But we are SREs, and what we do is we find toil, and treat that as an opportunity to do our job, which is to engineer a system that solves that. And in that sense, what I'm saying is, in this talk, is kind of the obvious, which is that we haven't yet done that in this area of the data recovery lifecycle, and we should just do that. So our mission is, the one that I'm trying to create here, is to build a reusable managed framework to back up, restore, recover a data store according to a tested plan. And because it'll be a managed framework, I hope it will be easier. That's the real goal, to make it easy. So this is my suggestion for what that might look like, at least in a kind of common case. I think there are naturally going to be variations, but we can think of it as this golden ring of precious data. And let's just go through it first. So we start with our production data. We create a backup archive, if that's the way things work. Sometimes it gets restored, which means you might get another version of your database that I'm calling the restored image, sitting side by side with your production database. And then you typically have some kind of batch processing or whatever that will look at that restored image, maybe compare it to the live data, do some processing, some verification, and potentially pour it back into production. And if you're doing recovery, you presumably are doing something to production because you need the data serving in production. So recovery means going 360 degrees around this ring. We talk about so this ring gives us a nice way of thinking about other ways that people talk about it. You know, just having backups gets you 90 degrees. Having backups and restores gets you 180 degrees. Getting that restored data at least through a verification pipeline so that you know that it's sane and you kind of know what to do with it is 270 degrees. When you are actually in a position where you have to recover from an outage, at least, you're going to go 360 degrees. And hopefully you can do as much of that 360-degree stuff beforehand in testing as you feel comfortable with, at least. So that you know it'll work finally. Now, one thing is that most of the hard work here should already be done by systems that exist. I mean, we have databases that store data, that can back them up, that can restore the backups. We can read from whatever we restore. Maybe this verification and recovery frameworks don't exist, but what I'm talking about that really is new is not a vast thing. It's this orchestration, this yellow circle that brings them together. And a simple version of it in where I have worked is, it could be 1,000 lines of Go or something like that to do the basics. And some of us might already have that, but it's not necessarily mature enough. It's not something that's you can generally get off the shelf and not have to worry about. If you've got that 1,000 lines of Go, that's your 1,000 lines of Go. We don't want everybody to have to write it themselves. There will always be some custom logic. There will be a configuration where you tell what all your databases are and where they are and whether you have storage, what your ACLs are, etc. And there probably should be a little bit where whichever the application developer is says, aha, I have a row that's come from my backup. I'm going to look at it and decide what to do with it. I'm going to compare it to my live database, or I'm just going to accept it, or I'm going to accept it if it's within this time range, or whatever it is. And that probably should be actual code, or at least in some cases be actual logic that's just completely custom. But that should be just one function, really. So we should have a place where we can slot in a little bit of custom code and config to control that whole big ring. So that you can just iterate on, when you're in that testing mode, you can just iterate on that little config and not have to solve the whole integration problem every time. Okay, so how do we get that? Which is another way of saying, why don't we have that? Because as I said, in some sense, it can be done in 1,000 lines of Go or whatever it is. Now, there are technical reasons. It is an integration problem, and integration problems are hard problems throughout engineering. But we are SREs, and solving integration problems is what we do, and it's what our tools are designed for and all of that. So that's not the reason why we're not where we should be here. I think the reasons are more human and more maybe social. So one thing is that it requires facing some uncomfortable truths, because there are actually some things that are genuinely hard, and I think that are genuinely a problem even if all of the tools were in place. So I said that we should be testing all the time, but restoring from a petabyte of data is an expensive process. There is all that data, it goes through the network. I've said that we want to do some custom processing on it. So even if we then just dump it on the floor and don't write it back, you've probably spent a fair bit of dollars. And if you do want to write it back somewhere, well, first of all, that's a dangerous operation. You don't really want to be doing it in production. And the unfortunate fact of life is some databases are curiously reluctant to accept large amounts of data, even though you think databases would like data, but that's the way it is. And these are real problems. So I've put that picture of the 3 monkeys who are looking a bit silly there. And it's as if I'm trying to mock the industry for hiding away from reality. But those monkeys are called the wise monkeys. And there's lots of theories about why they're called wise monkeys. And in Buddhist theory, they would say that it's because you shouldn't focus on evil thoughts or evil ideas, because you get paralyzed by that. But in the same philosophy, it says that you should be objective about things that are not good to look at, that are unattractive to look at, that you should look at them objectively. So we can bring a synthesis here. People have very good reasons to shy away from these difficulties in restoring data properly. So we should be empathetic with that. But those very reasons mean that by looking at those problems objectively, we can dissolve them, we can solve them. And it would be better if we solved them in the context of a reusable framework so that we didn't have to solve them every time. And that brings us to another problem, which I think is even more difficult, which is that there isn't a clear ownership of the problem. So our previous speakers were talking about ownership of data sets and models, but even just ownership of a problem can be quite complicated. So I am one of those colored men in that picture. In my case, I'm a provider of I'm an SRE on a storage service. And that puts me in a position where I have a lot of clients who want to be doing restore tests. And to be honest, we don't make it easy for them. So we do have that 1,000 lines ago I was talking about, where for our internal metadata, we do our testing. When we got a client to use our tool, it worked in the end, but maybe about every 30 degrees around that circle, you can see a record of a ping or an email exchange between the client and myself, me basically giving tech support for that, because it was a thin ring that just worked for us. And what I endeavor to do is work with more and more clients to go around that ring more and more times until it becomes a well-worn track that just works better and better and better for everybody. And that's, within Google, my ambition to communicate with lots of different stakeholders, with people who are mounting applications with our data store, with the underlying backup storage systems, et cetera. All of these people have a role to play and a possible diffusion of responsibility that makes it hard to solve the overall problem. So this talk is a call to action about that communication. I'm here at a conference, so I'm hoping to talk to people who are interested in this thing and learn about what other people are doing to solve these problems. So let's do that. We as an industry have an opportunity to engineer a thing. I think that a lot of our problems can be solved by just building something. I've talked about human things, which is really hard, but I feel that if we get some of those things lined up, what we can do is we can build some software that makes things a lot easier, at least within any given database ecosystem or whatever. And we are the kinds of people, the people in this room are the kinds of people who are in the position to either solve that problem or push for that problem to be solved. So let's communicate and get that going. Thank you.